Hi Algebra 2 students, this is the video that's going to cover the solutions to your study guide. So this will give you a chance to check those answers and to make sure that you feel fully prepared for Tuesday's Chapter 6 quiz. So let me just fix this on the study guide. We'll have one additional short review day in class on Monday, just to make sure that we get through the slides that we didn't cover for review on Friday. So first up in section 6.1, your goal is to be able to evaluate any kind of root operation, ones that you can do without a calculator using your perfect cubic, quartic, and quintic values, and then also the back and forth between roots and the corresponding fractional exponents. So the first one that you have is 25 to the 1/2 power, which if we convert it to be a root value instead, the 2 on the bottom part of the fraction will come out in front, and we'll be taking the square root of 25. Now that's technically 25 to the first power, so we don't have any exponents inside. And the square root of 25 is going to be 5. Now technically that would be plus or minus 5, and we want to account for that when we're solving an equation. But if you're just evaluating an even numbered root, it's okay to report the principal root, which in this case would just be the positive 5. For 27 to the 1/3 power, that would be the cubic root of 27 to the first, which is just 27. And from there, that's going to give us 3. Then these next two examples, we have some negative exponents. So 64 to the negative 1/4. First, I would recommend changing as 1 over 64 to the 1/4, which then becomes 1 over the 4th root of 64. So let's come over this way a little bit. Now 64 is a perfect square root, and it is a perfect cubic root. But if you go to your calculator and try to check it out using your 5th button under your math tab, 64 is not a perfect 4th root. So what we would need to do instead is to see if there are any perfect fourths that divide into 64. So we can rewrite this expression as 1 over the 4th root of 16 times 4, because 16 is going to be the perfect 4th root that does divide in. And we can then simplify that to 1 over 2 times the quartic root of 4. So this is a little bit of a combination of 6.1 and 6.2 material, but we can put them together there. Last one that we have here is the negative 125 raised to the negative 1/3 power. So you can think of it as if you have parentheses around this guy right here. So I'm just going to move that down to the bottom part of a fraction and have 1 over 125 to the 1/3 power, which is going to be the same thing as 1 over the cubic root of 125, which is going to be a perfect cubic value, so that one's just going to be 1/5. Then we've got some equations to solve in this section. So we've got a quartic, a quintic, and a cubic equation to solve. So here it asks us to round our answers to 1 decimal place. So we're not being asked to report an exact form, we're being asked to give an approximation. For number 5, we want to start by adding 2 to both sides. So that's going to give me 3x to the 4th is equal to 12. I can divide by 3, divide by 3. So that's going to give me x to the 4th is equal to 4. Then to undo that 4 expression, I can take the 4th root of both sides. That is an even root, so I need to include the plus or minus. So I'll have plus or minus the 4th root of 4. So remember, you want to make sure that you are comfortable evaluating any numbered root in your calculator. And so if we go to get this estimate to 2 decimal places, that is going, to 1 decimal place, that's going to be plus or minus 1.4. This next one, we have x to the 5th minus 3 is 343. So we're going to add 3 to both sides. And we'll have x to the 5th is 343. To undo that 5th exponent, I'm going to take the 5th root of both sides. And so when I go to take the 5th root of 343, I only need to report one answer, because given that it's an odd root, there's only one positive or one negative. So if we go to input our 5 and then find your root button, the 5th root of 343, if you just round to 1 decimal place, will give you 3.2. And then for our last problem in section 6.1, this one, notice that an entire binomial is cubed instead of just a single x. You want to be really careful to not do this. We can't distribute in that cubic root. So this is not going to work for this kind of operation. We need to get rid of the cubic piece instead. So if we do that, we're going to have x minus 4 cubed is equal to 100. So to undo the cubic part, I'm going to cubic root here, and I'm going to cubic root here. Now, depending on if you're looking for an exact form or a decimal approximation, you would either simplify, or if you couldn't simplify, you could just leave it in the exact form of the root as is. But since we do want a decimal approximation here, we're going to go ahead and get the cubic root of 100, and that's going to give me 4.6. So then when I add over that 4, my final answer is going to be 8.6 here. And so just watch out for ones like this that you have even valued roots, because then you'd have two different equations to solve with the approximate value. Now we're going to get into section 6.2. So this is all about our roots and how we can simplify them together, and also involves the exponent properties for fractional exponents. So this first one is a pretty easy one. We have 8 to the 1/2 times 8 to the 5/2. In this case, both of those fractions have the same denominator, so we can just add. So this will become 8 to the 6/2 power, which is the same thing as 8 cubed. And then we can just get that actual numerical value, which is 512. Then we have 4 to the negative 2/3 times 4 to the 1/6 power. And those have the same base, so we're okay to add, but they don't have a common denominator. So what I want to do is to write this as something over 6. And to get from 3 to 6, we multiply by 2. So I'll have negative 4 up top. So this will give me negative 4/6 times positive 4/6. So if I add those two together, I'll get negative 3/6, which is the same thing as 4 to the negative 1/2 power. And if I want, I can actually simplify that further, because that's the same thing as 1 over 4 to the 1/2. A 1/2 power is the same thing as a square root, so this would be 1 over 4, root 4, which is the same thing as 1/2. So I can make it look a lot nicer if I just simplify all the way through. Next up, another operation where we do have the same roots, or same bases, so we're good in that sense, but we don't have a common denominator. So we have a 1/4 up top and a negative 2 down below. This negative 2 we can rewrite as negative 8 over 4, because we're multiplying by 4 on the bottom, so we multiply by 4 up top. And then we're subtracting, so the operation that we're doing is 1/4 minus negative 8/4. So we're adding those together then, because minus a negative will make it addition. And that's going to give us an exponent of 9/4. So we're going to have 5 to the 9/4 power. Not really anything else we can do with that one, so we're stuck there. Unless we wanted to get a decimal approximation, but it's okay to leave that one as is. Last one that we're taking a look at here has some distribution and simplification. So we want to make sure that this 2 outside gets applied to every single operation inside. So this will become 2 squared times x to the 4th over, down below, this is 2 to the 1/4, so this is going to become 2 to the 2/4, and then we're going to have x squared. So then we can simplify from there. With our 2's, we're going to end up with 2 minus 2/4, which if I want my common denominator to be 4, will end up being 8/4 minus 2/4, which will be a 6/4 exponent on the 2. And then on the x's, we're going to have an x squared when we subtract. So the only thing that we really have left to do is to simplify that exponent to 3/2. So 2 to the 3/2 times x squared, and we're all done there. Now we've got some root simplification. So what we want to do is find any perfect values that divide into the numbers that we're given based off of the root that we're operating with. So go ahead and get your list of perfect cubic, perfect quartic, perfect quintic values. And then we're going to be working with square roots as well, too. So for 75, we want to ask ourselves, what's the perfect square that divides into 75? That is going to be 25. So we've got 25 times 3. And then we can take the 25 out in front and do 5 root 3. And if you want to include the plus or minus out in front because it's a square root, that's good practice for solving equations, but it is okay to report the principal root, which is the positive one. Now we have the cubic root of 56. So the cubic value that divides into 56 is going to be 8. So we'll have 8 times 7. And that's going to give me, I can pull the 2 out from the 8, and then the cubic root of 7 will be left inside. Last one, the fourth root of 243. I want to check my Quartic values and see what divides into 243. And the value that I find is 81. So if I do 81 times 3, that would give me 243. 81 is a perfect Quartic value because it's 3 raised to the fourth. So I'm going to be left with 3 times the fourth root of 3. And that's our final answer there. Next up, we have some operations with addition and subtraction of roots. So I can multiply any root values together as long as they're the same index. So I can work with cubic roots in multiplication and division. But when it comes to addition and subtraction, I have to have the exact same kinds of operations together. So here I have a 2 root 2 and a root 18. So I can't do anything about them right now. But I can go ahead and start simplifying that root 18 by breaking it apart to 9 times 2. Because 9 is the perfect square that divides in there. And then from that 9, I can bring a 3 out in front of the radical. And now both of my operations are square roots of 2. So I can add 2 root 2 plus 3 root 2 to get to 5 root 2. Same idea with problem 16. I'm just fine to add things together that have the exact same cubic root and then also need to have the same thing underneath the root. So the fact that this is a 3 and this is a 24 is a little bit of a problem. I know the root 3 is as simplified, the cubic root of 3 is as simplified as it's going to get, but I can break apart the cubic root of 24 to be 8 times 3. And then from there, I can pull the 2 out in front because the cubic root of 8 is 2. So then I'll have 3 root 3 minus 2 root 3, which is just going to give me 1 root 3, 1 cubic root of 3. And that's my final answer there. Now we've got a couple more of these. Next up, we're doing a Quartic root operation. So with the Quartic roots, what I want to see is whether or not I can pull out any values that are something raised to the fourth. But notice that the difference here is that I'm not subtracting, I'm multiplying. So here, if I multiply 25 by 75, I can work with that because I'll have 2 times the Quartic root of 1,875. So then I need to check and see what perfect Quartic roots could divide into that. And that final digit of a 5 makes me think that it's most likely going to be the 5 exponent value. So if you check your Quartic lists, 625 is going to work here. So 625 times 3. And then the fourth root of 625 is going to be 5. So we can pull the 5 out in front. So we'll have 2 times 5 times the fourth root, or the Quartic root of 3. And that's going to give me 10 times the Quartic root of 3. That's how I can simplify this operation here. And then the last one in this section brings us back to some square root operations. So again, we're looking for what perfect squares are in each of the values that we're given. So 54, we can break apart based off of what perfect square will divide into that number. And so if we check, 54, 9 is going to be the root that works. So we'll have 9 times 6. And then for 24, 4 is going to be the operation that works. And then for 63, again, it's going to be 9 that works. So 9 times 7. So now let's pull out the perfect square root values, and we're going to multiply them with the number in front. So this square root of 9 is going to be a 3. So the 3 times the 3 will become a 9 out in front. So we'll have 9 root 6. Minus, with our next expression, this 4, when square rooted, will become a 2. And then we'll multiply with the 2 out in front to become a 4. So we'll have minus 4 root 6. And then with the last operation, this 9 will square root to become a 3, times the 4 will become 12 root 7. So only the square roots of 6s are going to be able to combine. So we'll have a 5 root 6 plus 12 root 7, and that's going to be as simplified as that expression can become here.